Everybody, good morning. This is Engineer Suraj Singh speaking from Bharat, India on this day, March 28th, 2021, Sunday. A day of life, Sunday. Great to see you again for purpose of debating, conferencing, talking. Of course, you are invited for any question regarding to whatever talks I make. I try to do my best based on my whatever small experience of life in engineering and otherwise. Engineering and otherwise I am saying because it's not simply engineering that makes life, it is otherwise as well in every affair of life. You can say topic being civil field engineering, designs, construction methods, contracts, quality system and organizations, communication coordination. Means it's kind of no specialized talk but general talk, because generalization is very important in our field. Specialization can be applied only for specific purpose, whereas general requirement is on top. When we do work in field, in construction particularly, where whole savings of life are involved, that saving expenditure is not an easy one which can be taken for granted. Unfortunately, in majority of cases, this expenditure is being taken for granted because quality criteria, which must be number one, is not practically considered number one. Rather, compromise to adjustments are accepted for your money, which means your hard earned money. If you are really interested in good structure, this structure which you get or you intend to get works for you for more than your lifetime, for more than lifetime of your first child, then second child, I mean to say your grandchild, and then that grandchild, maybe for 4, 5, 6 generations your structure works. But do you take care of quality criteria to that scale? I find when you buy some small item like vegetable, like some food, like something else, which costs very, very little amount if you consider percentage wise of your whole earning, and you are too concerned about quality of that. This vegetable is not today's fresh, this vegetable is septic, or this is not fresh, or this biscuit is what's expiry date, or this which you buy for couple of days, say check what's time with, how can I best use it. You are very much concerned, and that's good quality, I should say, good quality of every buyer all over the world, if you are so concerned about this. But point of view is different here. When you spend whole your money and even you take loan for your house construction or for some structure, or even in public places where public structures are done through government or through some other private owners, bridges, flyovers, roads, whatever, to what extent quality criteria is kept in mind? That is very important point. It is unfortunate that that point is not taken care of to an extent it should be. It's everywhere, you can see it's everywhere. It happens that we don't care about that, and we only hope that I got a house, I made it, I purchased it, and I'm lucky. That lucky scenario, works for you and you feel happy with that. That is actually, I should say, I should say that's really unfortunate, I may say, because quality should be number one, and that quality doesn't mean quality of material only or quality what they explain. Who purchases and who buyer and purchaser and claimed by shopkeeper or builder or promoter or whoever does it or sells it to buyer tries to convince in a way that this is best one in world. Unequal, you can't buy like this somewhere else. And that is where problem lies in. You see, a person who is a seller, could be promoter, could be builder, could be whatever, that person has to earn a lot of money from you, maybe to an extent of 25% of investment or more. Sometimes land costs are very high, but your money gives you quality product is a big question mark which you have to question yourself and then answer. Okay, this is lifetime earning. You get a house or structure for public use. Your money, it is your taxed money, it is your savings money, it's your earning by your hard work, if you think it is, or it is robbed money, I don't know. I don't think that it should be robbed money or stolen money. I think this money belongs to you and you did worked long years for this. So it's a question for you. Whatever you spend on home delivery, I mean to say house delivery or building delivery, it may be apartment, it may be your own house, or it may be something else, your public work, because it's also your work. How many people do concern about system of quality and product quality? I am saying system of quality because there's one gross part of quality which must contain product quality as well. And product is structure. Product is other permanent items. But most caring one, to my understanding, and must be to your understanding, is quality of product, quality of structure. If a structure is like, you can say, anatomy of our body, skin is one part, but anatomy, or you can say system of bones in our body, who rules over system of others. If we have some problem in our body, in whatever part, we feel pain and we complain. That's okay. We complain and we get treatment because we feel pain. But in building or in structure that you buy, do you feel pain or you compromise? Or you don't care before buying, prior to buying, you have no consideration. If you have, that's fine, but you will be convinced by seller, yeah, it's best quality in world, don't worry. I got material from that country and that country. That statement shall make you happy, and you say, okay, no problem. You have to pay all time, you will pay installments, you will pay capital, so whatever means your payments, and even then you won't be given quality. So that is one point I am very much concerned on. So this quality plus, this is not simple material quality, this is complete quality. You must get back what you pay for. That's what business is. If you pay for some amount, you must get back that. And if you don't get back that, means you lose somewhere something. So that quality criteria is extremely important, and that's why I keep it number one page. It's number one, quality system quality, quality product quality, quality structure quality, like that. Of course, I can say, and you may say also that I'm not engineer. Yes, you are right, you are not engineer. But are you agriculturist when you buy vegetable? Are you agriculturist when you buy flour or wheat? You are not. Or you buy something else, you buy some clothes, are you textile engineer? You are not. When you buy water, are you public health engineer? You are not. So it applies to everything, but because you consume those products every day, you have experience of taste, experience of digestion, experience of smell. So you say, yes, this is good one, this is what I expected. But because you can't have experience of structure, yes, you look at finishes, you look at decoration, you look at paint, you look at good work, doors, windows, lifts, service, how fittings working, electrical fittings, how HVAC working, what is color of this, how what floor it is. You concentrate on that rather than asking questions about structure. And that is point where lapse lies in. According to my understanding, lapse lies there. Where? Structure. Maybe it is building apartment, it is your plotted house, or it may be flyover, or it may be road construction, it may be sewer line, water line for public use. Wherever you are involved in walking, you walk on footpath every day, you walk in street, you take tap water or you drink bottled water, wherever you do whatever, you have many questions and you just sometimes agree on whatever it is. Means you say, oh, it's beyond my control. Yes, that is beyond your control. But whatever is in your control, within your control, do you take care of that? You don't take care of that. You only pay, okay, I am paying, I am booking for this house, I must get in 3 years. That's what you think. And you think it's a lottery if you get it in time. Or you wait for another 3 years, and they know. Government knows, public, those agencies who deal with that, they know. And promoter knows, and agent knows, and of course at end you know that you won't get it in time, even then you pay. You don't realize, you can say, merits and demerits or good or bad of that. That's where my talk is related to. It is quality of system or system quality, and also its quality of product and product quality. These two are very important. And other point is, when you talk of system quality, it doesn't mean system that works there. It's people, it's personal, it is top, middle and lower, all category of people, staff, personnel or officers or managers or organizers or leaders, whoever are involved, they all are related to. Everybody has got some quality angle, quality aspect, quality valuation that must be considered of. What sort of owner of that organization is, what sort of directors they are, what sort of commitment they have, what's their quality policy, do they commit that one or just on papers? They have documents for construction, do they commit, do they conform to them? That's a point of concern. Do they? But who does? I am sure you don't understand all this, because this is very much high profile technical issue of contract documents. But what is done on site, you know only that. And that is just 15% of what is available. 80% works behind, which you are not aware of. And that is only objective. I am trying to reflect to all that what is quality about. Quality is not related or is not housed in only in materials, but quality is housed in every affair of project. And project means, project is day when you promoter starts something and day when that delivers to you something. This whole duration is called project duration, and this stays from that feasibility to delivery to you, possession to you, occupation to you. That duration, that system, that process completely we call project. There are so many projects in every project, sub-projects, discipline projects like that. We'll discuss that. So all this must be quality. Just do not concentrate only on construction. Construction is like film, what is projected on screen. There is so much behind that. Don't depend on the heroes and heroines. Or there are so much behind Nuno, and that's the same thing. There are so much behind our construction work that is done on site, that is seen done, and you think this is only that. No, much more lies behind. Behind lies a documentation of contract. Behind lies designs, and behind like that, feed, that's front end engineering design, and behind like all codes, theories, and practical experience, and lies behind whatever else you can't even imagine. Means whatever you understand is happening on site, that is just 1/7 of what other 6/7 which is not clear to you, but engineers know it, and unfortunately they too don't bother about that. They only say, okay, my work is done on site and that's enough. That is one part, but 6/7 part is not known to. They don't care about this. Okay, let designer take care of designs, and let planner take care of planning, and let all other professionals take care of their respective disciplines. And similarly, let means they concentrate only for their job, and there where I say integrity is lost. Integrity of team, integrity of all project personnel is lost, coordination is lost, communication is lost, and particularly when it is computer world, it should be better than it was before. I think it's worse than as it was before. When I was young, that time there was no computer. When I started my career in 1974 after passing my 3 year civil engineering diploma, and continued this career after passing my degree in 1980, in those days quality was better because there was no computer. People used to write, people used to calculate, people used to think, people used to analyze mentally by writing, by calculations. You of course used to take a long time, but mind got very much too much writing power, too much speaking power, too much concentration power everybody had. You think of, if you design manually these days, calculate some bending moment, shear force or deflection, and find out design manually. Of course this will not give 500 pages, but your mind shall work faster than your calculation, and results will be much more becoming than what we have today. I'm not going to criticize that one, but that was time. Now it's different time. I can't oppose computers, but computers should be used as your servants, as your tools, and not dictate you. So quality is very much part of this, and quality is dependent on whatever designs you have. Designs of what? Designs, structural design, or you can say other design, or calculative design, or design means whatever process you think of and reach certain decision, that is called design. Means I have to design something for what kind of plaster I have to do, what kind of work I have to do. Or it's not only in building, but every part of your life. Means what I have to do something, what is in my mind, what my mind should decide, for writing, for speaking, for calculation, for whatever activities involved in, for planning, for processing, for spending money, for reducing expenditure. All that a kind of, you can say, certain designs in your mind of everyone. And structural design is dominating in our field, because structure means first we have to design, and first before designing we have to decide cost of that, cost element of that structure that has to be included in permanent works on that structure or building. You can say what percent is that, 20%, 30%, 40%, 50% of whole budget, or 40% of whole budget. We have to think in that way, because major part of building costs go to finishing items, services items, electrical services, mechanical services, HVAC services, or you can say plumbing, public health services, and solar panels, and all other services, water supply, CCTV, you can say, or other security services. Whatever service we consider into our project, all those are much more expensive than cost of a budget of structural elements or structural anatomy. Of course it takes much more time than all other service, because a structure has to be done on site, and it's very important part. Without on site it takes most time. If it's cost sensitive, we do work on site and do it, but cost is not extensive cost of all other rest. Some of you'll find structural costs not that much, is maybe it's much lower than all other costs, but other costs, other materials which are other disciplines are generally procured, means those are done somewhere else, and we get them delivered 80-90%, and they're just installed. For example, HVAC equipment, elevator lift, you can say, or conduits, or you can say electrical fittings, or plumbing units, and whatever we say, these are just readily available, or we order them and get them, we install them. So 10 to 15% work is done only on site. 82% work is done somewhere else, off sites, or or some in other factories. So that part doesn't consume that much time. So structure consumes a lot of time, because we have to take care of structure everywhere. So we can say there's a difference in designs and construction. So it's a construction plus. When I say construction plus means, when I say plus, it doesn't mean construction only. Just like I say quality plus means it contains design value. Quality itself is a design rather than structural design. You have to design first what quality system you want, and that design based on what type of construction should be. And construction plus, I can say construction, when you do construction, what methods you have to adopt over that. So that's also linked to that one. Method statements, I can say, is only solution for everything, even for designs, for, you can say, for quality, for construction. Methods means everywhere methods are involved, and whatever methods you think, maybe in your mind or by convention or by your design, you can think of what way I do best for this work, and that method is very important. Then you can say time comes. Time means all this linked to time. What time you have for project, what's required when you have to commission this project so that its returns start coming in, and that time is related to all foregoing points, as I said: quality, designs, construction, method statements, time. And then of course time means cost. If you deliver a project in time, means cost will not enhance itself, cost will not go higher. And that time, if you delay this time, means you have to spend more. You will, first of all, you will lose your earning. Maybe you suppose you lose 10% to 15%, 20% time of project. That means that much return that had to come either through use of that is lost. Cost is enhanced because you are spending more. Time is very effective, so you can say kind of risk. If you lose time, it's risk, so you lose something. Or if you gain time, is you do proper delivery, so you get benefit. And cost is also affected in this. So, and these two items, time and cost, relate to risks. Means what are involved means your business is delayed, your commissioning is not done, project is not started in time, so you lose earnings. Power station is not done in time, it's not commissioned, or plant is not commissioned in time. So that links to that one, and that's a kind of risk, means what required somewhere else, and that sequence is also affected. Those, although who are consumers of that services, they're also affected, and that's what's called, then come to reliability, which ultimately affected because people used to rely on that. That's first part, means this project, this which you had to deliver, was supposed to be safe for something, and it was supposed to be selling service or delivering service or product service. And then also it had some longevity that should be considered in view. For buildings are considered more than 100 years sometimes, and these plants may be considered more than 30 years to 60 years depending on how continuously they do. And similarly, all these systems, all these points in talking to you, these relate to certain analysis which is conducted. Analysis is conducted, synthesis is conducted, thinking is induced in automatically, and contemplation is a formula for that. So you want to find problems to solve. You have to find problem first. You can solve them. So that process, that column in this, I can say column in this or beam in this. You may say analytical column. It doesn't mean it's a structural column. This column is different. Analysis. What I mean to say, this column is very much different in the sense that this column is assumed, analysis. I can say you have to analyze something. Analysis is a very important point. If you can't analyze, means you have to break something into many parts and see how does it work, and whether it works rightly or it doesn't work rightly, that you have to decide and set it right. And that's called analysis. It means you have to break, let us say I have to analyze my body, I have to break my hand, I have to break my legs, and then study everything. I'm not going to do that, but I'm just referring to whatever item is there. We have to check each and every part of that item in that spirit. And then we find solution. After that analysis is done, those solutions are linked together like machine parts are assembled together. So assembly of those solutions, you can say, is a synthesis. Analysis and synthesis are linked. Synthesis is a child of analysis, and all these babies are linked together. That's called machine. So analysis of machine and every part of that gives to modification or amendment or add more part to that, and link all those assemble all those part into one unit, so that they work in a way a train works, in a way processing plant works. So internally in your machine there's a processing plant, maybe there are 100 parts or 50 parts in that machine, they work together, assemble together, and that's called synthetic work, synthesize. Then all this was based on thinking, analysis was based on thinking, synthesis was based on thinking, quality was based on thinking, methods were based on thinking, and you can say whatever you see, construction, all this has some thinking basis. So thinking rules everywhere. You can see it's a graph of thinking, it's a geometry of thinking, it's you can say grid of thinking, and all this can be called concentration or contemplation, because you form many templates for each item. You form some template, then other also and there may be many more templates for one item, but there may be many more templates for combination of items. This all templates, when you combine together, maybe hundreds, maybe in 500, maybe in 1000, maybe 10, maybe 5, means all this work is grid of templates, grids of template, and that work together like network works. And you have to see how many grids you have in your project, and then you can say all are these working, all work together, all shall work together as far as project operation is concerned. And project doing is called application, project design is called application, project all activities are called application, doing project is called application, and then after that project delivered, and otherwise also you can say it's processing, it's a system, it's you can say performance, that comes under preview of you can say operations, and that's also called application. So that's point I like to just emphasize on. What is quality, what is design, what is construction, what is method statement, what is time, what is cost, what is resource reliability, what is analysis or synthesis, what is thinking, what is contemplation of the application. This is all I wanted to talk of in this way, so that we can at least understand what we are going to do before going further, because this talk is for method statements. That's very important point here we have to consider. And so I would say I talked yesterday something, and before yesterday something. Is in continuation of all those, that we are here to sit and see what we can do, and that's very important point, that we have to do this. So in this case, let us say this is, I say here, this is a building, non-plant building is here. It's shown non-plant building means buildings which are, I talked of this, and now, and therefore I talked of also this building, this, that is, you can say it is building house, you may say this is building house here, which we talked of that. And also I talked of earthquake management, something is not directly related to earthquake, but role of site engineer is very important in this, which I was talking, role of site engineer. And then I think I have to then it is my certification of chartered engineer, just for information. This is nothing to something else. This is my certificate of fellow. I am Institution of Engineers fellow in India. This is my fellow, and this is my, of course, reapplied now. It's old. It's is gone. This engineer certificate. It is valid up to 30th September 2020. I already applied. I didn't get answer till now, but still, I am on roll as international professional engineer in India. International professional engineer means I can use INTP India title, and this is under statutory rules, under agreement of International Professional Engineers Agreement, where 15 countries are members, and India, Bharat is one of them. Just for your information. And this is a FI that I close now. This is a FI I'm closing. And also this chartered engineer certificate I'm closing, because only informative purpose it was, and I can say I can close it. Now I'm now again deliberating on role of site engineer. Note, prevention capacity building approach. This is I defined yesterday as well, that prior to deliberating role of site engineer or whatever job, we have to understand what does it mean. And we talked of site engineering. What is it? Definition in nutshell. That indicates a chain of various engineering works, descriptions belonging to all disciplines, starting from tender stage to handing over and maintenance stage of delivered building or structure of project. Then I talked of supervision end and contractual end, where I described what is supervision end, where Engineer is responsible for supervision, resident engineer is responsible, engineer is a person that's defined in contract. Engineer, contract engineer, or you can say engineer defined in contract. It's not simple title, it's title in contract. Contract, that is a document executed between owner and contractor. Owner is a person whose project it is and who invests money, who takes all liability, whereas contractor is a person to whom work is given to be executed. Maybe it is EPC or it is construction work, that's called contractor. So contractor and owner have contractual relations. Owner or promoter or whatever you can call, that person has contractual relation. That contractual relation means that person, though those two persons have their agreement, that agreement exists between owner and contractor. Again I'm saying, and contractor is second party and owner is first party on contract. That is their contractual relations. It may be construction contract, it may be design delivery contract, design and construction delivery contract, whatever you can say, there's capacity up to. So engineer is not engineer is not a party in that contract. Engineer is just the administrator on that, you can say. Engineer administers that contract, and that administration is very important, because otherwise it's not possible how to do that. Administration is very important in that part. And engineer doesn't mean that engineer is a party. Again I'm saying, engineer is not party. Engineer is expert there to help owner control project, because owner cannot control directly due to profession, and owner is owner. If owner is engineer, that's different. But if one requires engineer, like patient requires a doctor, for engineer, that owner is a patient, you can say, or that engineer has to support that project rather than supporting owner. When the project is supported, owner is supported. That's relation exists like this. So on supervision end, there is engineer, non-party on contract, on construction contract, and that person employs resident engineer for assistance on site, and resident engineer has got many other associates or assisting engineers to help them. Then on other hand, you can say of contracts, this contractual engineer I explained to you, is contractual engineer responsible in total contract scope legally without being a party. But this contractual engineer may have another contract with owner, or management, organization, or services, second party, where owner is also first party. So that's on supervision end. And if you go to, I'm not defining our chief engineer, all that you know very well. The chief engineer is there everywhere in government department, who is an engineer actually, and he employs a chain of engineers who are all subordinates or resident engineers. And if you go to construction end, you can say this was construction end, where I defined contract, and on supervision end there's another contract, another one. That was only purpose that I wanted to explain to you what it is. You should know how project works. And of course there's third party consideration. These I will explain to you later on. Now it's only just briefly I'm telling you role of engineer, and role must be, is written EQ management in this. Don't be confused with that, because this was a file I addressed to many engineers in some state in our country, and that was training engineers for purpose of engineer roles. So don't worry about that. This role of site engineer, it may be EQ related or not, everywhere there's a role. So engineer I defined, engineer is person responsible for every aspect of contract, not civil alone, all disciplines, and resident engineer, associates, etc., and similarly contractors there. So there are two contracts, three parties you can say on every project. In consideration, basic fundamental three parties, three persons, you can say triangular system. One corner is owner or promoter or builder or whoever. That is party number one on both contracts, on construction contract or EPC contract, or on design and organization contract or management services contract. So one contract is construction contract that exists between owner and contractor. Other contract exists between owner and engineer, or engineer may be staff of, it doesn't matter. Say, then we can say I define resident engineer, and on contractor and there is another one which is equivalent to resident engineer, same key, and that is site representative of of contractor, which is called site agent as well, or project engineer may call, or project, or whatever you call means it's up to you. I'm not going to force on that. But the resident engineer, when I say there's a representative engineer, and that also you may say, if not site agent, resident agent or contractor's resident, you may say, it's up to you, resident engineer's resident or contractor's resident. It doesn't make a difference to me as far as title is concerned. Role is more important rather than title. Title is mere, and even in resident title, this doesn't work in our country, but it works elsewhere. So it's only meaning, I'm telling you. You may call whatever title, it's up to you. There's no argument, there's no thrash on that. Then resident engineer, I said site representative, then all engineers, supervisor engineers. Okay, the site is all site staff, contractor including subcontractors report to site agent. Size and magnitude of project demands number of further site staff to meet requirements. Many site engineers, so practically dedicated to supervise all works, may be employed on various sections of projects, and many constituted teams under senior site engineers or construction managers. Now various sections are organized under quality system on all projects, and these sections, you know very well, everywhere this work, and nowadays these are, previously in we go 1980s, 1990s, this was a combined work for one engineer, safety plus engineering plus planning plus contracts plus construction plus surveying plus like that. All these generally were done by one or two persons available on site, because in those days there was no such quality system. There was no existence of that, there was no existence of like that. So now there is safety, which is number one. Number one is not an authority, but number one in precautionary measures, number one in direction. Because first, wherever you go, where you work, safety is considered first. Means you can't go blankly, you cannot wear sleepers and go, you cannot just keep your head exposed to weather, you can't go. No, you can't do that. You can just walk in everywhere, you can't do that. You must abide by safety, that's called HSE, health, safety and environment, added, supported, and also ergonomics. So you can say health, safety, environment and ergonomics. Like that means health is, you should be healthy, you should be safe, you should work in good environment, and you should use science of or engineering technology of ergonomics. So like that you may say it is safety, means you should be safe, your subordinate should be safe, your crew should be safe, your site should be safe. That is what safety is, HSE we call it generally, health, safety, environment, and then of course use of ergonomics. And ergonomics, I mean to say, erg is called unit of energy that is being used on work by everybody should be optimally used. It's not that you waste your energy and get tired and fatigued and say I'm tired, I can't work today. That's also loss of project time. So safety is first part for purpose of works. And then comes, you can say, safety lies everywhere. Even in design office there should be safety. In contractor office there should be safety. In engineer office, safety is different type of safety. Safety regarding no cable should be loose, you should drink water, there should be no hindrance in walking even in office. And when there's a break of fire, how to exit. Like that safety also works there. Means it's not simply it works on site, it works everywhere. Safety when you walk on footpath, it works. It works when you do whatever work. You drive a car, it works. You drive a scooter, it works. You sit on chair, it works. You work on computer, it works. It works everywhere. Ergonomics works. What is your sitting style? What is your walking style? What's your exercising style? Means everywhere it works. So safety is omnipresent, you can say, as far though should not say, but omnipresent. Then comes engineering part, and engineering part means complete engineering from feasibility report to complete handover of project. Engineering comes to the picture, but when I say engineering, in fact I say in designs and in construction, those are major dominant domains. We can say engineering works. Engineering in feed. Engineering field means front end engineering design, we call it, works there, which is more disruptive. It's not simple engineering, it has detailed engineering and visionary engineering. That is visionary in a sense that you have to imagine what design formula, what you do, how to process design, and then detailed working drawings and detailed designs, all those engineering. And also during construction there is a relation to engineering. Engineering doesn't end at design delivery. It works further also during coordination, during communication, during review of design, during Further, if there are clashes among various items, we have to solve them, resolve them. That's also part of engineering. There are so many queries raised during construction because there's a conflict in designs, or designs do not talk to each other. There's an interface problem, there's intersectional problems, and those problems are resolved by engineers during engineering. And that's also engineering means, and also quality engineering we can say. Then we can say also they are planning engineering. Those are also engineering, planning engineering. Though we certainly are planning, this is a planning, this is scheduling out. No, it's not scheduling out. There are problems also during construction. You expect there are problems so many. So planning has to take into consideration complete schedule. And the schedule can be, or you can say bar chart or CPM of part can be drawn only if you know thoroughly what project is, what the scope of work is, what time is, how much resource force we have to apply. That we have to understand. And that's planning engineering. Means planning is not simply drawing bar chart. Means you should have complete thorough knowledge of that project. Means you have to consider time there, you have to consider cost there, you have to consider quality there, you have to consider all other factors that come in. And you can say long lead items you have to consider how fast, how can planning support site persons to expedite this project. Everything should come into picture. It's not simply drawing charts saying this is the cost, this is the cost. It's not your duty only to use cost control in your planning. Cost control is one part, but real planning is that you have to consider each and every factor, and that's all called planning quality system, just like engineering quality system, safety quality system. And then we come contracts, and contracts is a very big domain which engineers usually run away from that because it involves law also, it involves business also, it involves public dealing also, it involves workers, it involves machines, it involves all resources, it involves marketing. Means it involves everything which others do not involve. So contract is for engineering, it's complete different world. Means it's the engineering world that is contract. We cannot stay in context by stating, oh, there's no comma here, you provide comma or column, semicolon, apostrophe. We cannot talk of, that's not required. Essence is required. What my provision on contract, my clause on contract, or my, you can say, article on contract states, and how this is linked, or we use FIDIC, or we use civil engineering new, or we use some our contracts standards, or we devise new. Whatever we do, it should be according to National Contract Act, it should be according to international provision on contracts. So contract is that part. It's not simply the two parties. It's contract term itself says track, you are moving on track, one track, another track. Owner should be, contractor should be, they should move on same track. One should not say I am ahead of you, or I am, no, you can't say that. Both should move in unison. And of course, though there is no contract relation, but other person is engineer who is driver for both. You can say pilot for both. Engineer drives both, owner and contractor. So that's what contract says. So one must have knowledge of contract. Means it's not simply contract law. Your whole contract documentation itself is contract. Maybe thousands. You can say drawings. First of all, you can say contract form, contract agreement, which is number one, contract cost. Then project contract related, like you can say particular contract, particular condition, general condition. Then you can say specifications, whatever specifications, and then you can also say whatever drawings you have, whatever other documents you have, whatever is there, all is contract. Codes, national laws, everything that comes into that ambit is contract. All schedules, whatever are there, are contract parts. So contract is very complicated, but it's not difficult once you understand activities, once you understand once you understand how you have to move, means what is scope of contract, how you have to move that one. If it happens, you can say you are somewhere in world of contract, and this contract is very important. Unfortunately, engineers are not taught, particularly in our country, Bharat, India, they are not taught of contracts to that extent. Should be due to limitation of, you can say, scheme or program of degree, or and people in post graduation and others, they don't care about that, and that's not good. Because if engineers are defeated in field, they are defeated because of lack of knowledge of contracts. I have seen British engineers, particularly, they realize what contract is. They beat contractor because they have knowledge of contract. I'm very much impressed by that, by those people, that they are practical. Why we say, oh, let contract engineer take care of, or let advocate take care of. I don't accept this. Legal luminaries are different. They have no contract knowledge, they have no project knowledge, their work is different, but it's engineer's work. Of course, you have to learn some knowledge about law, you have to know what is contract law, you have to know what is labor law, workers' law, you have to know how materials are procured. That by virtue of experience we can get, but we cannot simply deny that. It's your duty, it's contract. You have to understand contract, you have to understand what are meaning of clauses, you have to understand that. What rights workers have, how we have to care of machines, how we have to purchase, how we deal with people, how we have to write, how we have to communicate, how we have to coordinate, how we have to coordinate all documents together, contractual document, technical document, non-technical document, this document and that document. We have to do that. So it's very important part. I think this number one we have to do, we should understand contracts first. If you don't understand contract, then there is no meaning of safety, there is no meaning of engineering, there is no meaning of planning, there is no meaning of construction. Construction, when it comes, construction, and say everything is structured in. When you say construction itself, it says safety is in, engineering is in, planning is in, contract is in, surveying is in, quality is in, material is in, administration is, everything is in. So construction is the dominating part, you can say. Whoever did before, all that. Design is converted to shape, reality, physical world. It is an asset. Construction means creation of assets. Right? Construction comes, so today I construct, tomorrow I demolish. You can't do that. Your permanent material, permanent product works for centuries, sometimes decades. So that is dominating part, that's part which gives an asset. Your building is an asset. Every civil engineering product is an asset. Because other products, you buy vegetable, 2 days it's gone. If you take clothes in 1 year it's gone. If you buy television, 3, 4, 5 years it's gone. Your mobile 3 years is gone. Whatever you buy in your life, except your building, except a structure, everything goes away. Your structure can't be taken out. Oh, I destroy this, I buy another one. Nobody does that. Yes, in 100 years, in 200 years, that's different. But no other item, no other article, no other good that you buy, it can go in 2 years, 3 years, 4, after that it's obsolete. Oh, this computer I purchased 5 years back, now it's no meaning, it's not repairable. A mobile I bought 3 years back, now it's obsolete. It happens. In this car I bought 5 years back, it's now no meaning, there's no market value of this. It happens with clothes, it happens with all your electronic items, it happens with all other items, your kitchen item, your furniture item, this and that, means it happens. Before furniture was of timber, it was long, now it's also plastic. So you can't say that. So what I say is, it is only asset that comes from civil engineering. Assets do not come from electronics engineering, assets do not come from agricultural engineering, assets do not come from mechanical engineering, assets do not, even power stations main parts are replaced from time to time. Electrical parts are replaced from time to time. In your building you change bulbs and tubes and all this, maybe in 1 year, 2 year, 3 year you do that. So there is only structure which doesn't go somewhere else. Even you can change plaster, you can change flooring, you can change everything, but you can't change constructed structure. And that's where I stress, only structure, that is number one asset in this world. Then you go surveying. Surveying means it's seen done, but it's not measurable, but it is dominant on construction. If you don't understand survey, construction can't be done. It's impossible. So surveying is possible. Surveying is king of construction. If surveying is incorrect, construction is incorrect. It may be horizontal control, it may be vertical control, it may be angle control, it may be circular control, it may be curve control, road control, building line control, whatever control you can say. So quality means this quality is different. I'm not talking of the system quality, it's quality of work, quality of workmanship, quality of material testing, what material you are using, what equipment you are using, how you are producing, what's your method, what's the procedure, and materials as well. And then on top of that comes, it means that to do all this, we need some additional support, that's non-technical support for arrangements, for administration, for something to happen in time, or that work which doesn't come under purview of technicalities, that's administration, means helping everyone so that money flows in time, deliveries are made in time, stores work well, camps work well, workers work well, support them, food is given in time, all that. This is, you can say, different types of work, and you can say are various strong model typical sections established on generally every site. So this is why I say these are very few, means there can be more. There is no limit to that. Now we go to certain thing about discuss, role of site execution, and as I said, based on this discussion, you can see this planning, there's mobilization, there's surveying, kickoff, construction, quality supervision, complete all that, and then of course it says earthquake management is involved in general with the site engineering conditions, and site engineer has no definite independent direct role. Site engineer has no definite independent direct role in earthquake management, but indirect role to implement design, engineering and project decisions to comply with quality system with strongly extended base support by all responsible discipline sections on project. Site quality plan and site safety plan must describe functions as well as supporting roles to all responsible engineers and personnel, officers, directors, everybody. Site quality plan, or you may say project quality plan, project safety plan, and you say quality and safety, and project plan itself. Project plan which empowers all these two, and project plan gives you complete particular plan for that project. I'm not talking of general plan of companies or organizations. These three plans are very important. If they are described well, it's okay, fine. Plans gives directions, and these can be updated from time to time. I'm talking for all projects, means project plan, quality plan, safety plan, whatever. Then site agents representatives responsible in all respects for site role multiplies as follows. Design review. Let us say what is design review. It is first involvement to make sure that design specification requirements have been included within design review, and you can say design review is first involvement to make sure that design specification requirements have been met, have been included within design philosophy. Engineering section does it. Engineering section. Soil report requires a thorough review. Through engineering section, it's to be made sure that all recommendations included by soil or geotechnical engineering have been covered within design report. In case of whatever pinpointed observation, it should be brought to notice of designer through agreed procedure. Should also be specified on design drawings, a specific value of soil parameters adopted on design. Certain parameters must be confirmed on site prior to laying foundations. In case localized soil doesn't allow adopted design parameters, design should be reconsidered. It's responsibility of site engineer to conduct this test in all major areas of site using services of laboratory or metal testing laboratory. It's not written here, but it is like that. Site quality engineer has to involve for quality accuracy of test. Whatever variation from soil report should immediately be reported to soil laboratory and designer. Resident engineer has to make sure that testing system is complied with. It conforms in line to standard procedures. All relevant engineers must sign inspection and testing plan, ITPs call it in short, for such activity. Testing of all materials according to specification requirements must be conducted to ensure the mandated quality. Adhering materials, particularly reinforcing bars, being an important item for purpose of procurement, rightly. Concrete trial mix should be also be carried out or conducted so that right quality required mix is produced to meet design requirements. Piling should be done fully in compliance to specific designs and test load requirements. Load tests as well as integrity tests must be rightly, satisfactorily conducted on them after these are done. These are cast in. It may be a continuous flight or may be different one. Connections between piles, cutoff level and pile cap should be rightly and satisfactorily done, made. Test piles activity must be conducted much in advance. Site engineer through engineering must make sure that all drawings contain right tactile detailing of reinforcement. In case of whatever detail missing, should raise immediately query for confirmation. Arrangements must be indicated on typical standard drawings by designer. It's very significant for proposed materials to resist earthquake forces, which included materials should conform to standards without any adjustments. No compromise should be made in quality of these materials. Generally, it is reinforced cement concrete that is often included on various buildings, and it is certainly considered for designs. It's therefore significant to produce concrete works with good quality, and no batch of concrete should be allowed to be poured unsupervised. Site engineer must ensure that whatever precautions are required to be taken on site or resorted to on site should have been explained to all responsible skilled craftsmen, craftspeople, persons, workmen, work crew, as well as supervisors like foremen, supervisors and charge hands. All requirements should be included on relevant methods statements clearly. All detailed method statements should be approved ahead of every activity. No activity should be done without availability of approved method statement. All quality controls must be conducted during concrete pour. This may include slump test, air voids, volumes, concrete temperature, concrete mixing to concrete finishing time, etc. All reinforcing steel bars details must be produced in form of bar bending schedules prior to giving to fabrication. These should meet requirements to avoid stresses, localizations. As far as practicable, overlaps should be avoided. Rings or straps should be fixed in such a way that hooks do not continue on one side. It should be remembered that reinforcing bars during earthquake action time change behavior drastically. Bars provided with gravity loads start accepting horizontal shear distributed stresses, thereby as well forcing beams to work partly as columns and columns to work partly as beams. That makes an essential requirement to tightly bind all bars, and no bar should be displaced during concrete pour or during vibrator application. Vibrator must not be allowed to touch any rebar any time. No over vibration should be allowed. No pulling off or pushing off concrete mix using vibrator should be allowed. No segregation should be allowed. All concrete must be vibrated. In case of voids formation, thorough investigation should be conducted and then remedial actions resorted to. Proper inclusion of concrete spacers, also called concrete covers, should be made at right location so that rebars keep intact during pouring activity. It has generally been noticed that this item is neglected by site engineers as well as other persons. Cover is too serious an issue to be considered. Precast covers well cured can be used. Plastic covers, if strong enough to bear loads of foundation rebars, can also be used. Formwork should be erected based on correct and safe designs of preparatory works. Safety is of utmost importance. Safety first criteria should be fully considered and implemented. Well, in addition to usual quality control tests such as slump or cubes, compressive strength, Additional tests should be conducted for cores drilled or taken out from various locations to make sure that site conditions match laboratory conditions for cube testing purpose. Curing is responsible for life of concrete and therefore must be given due care and control under direct command of a responsible staff. No leniency or worry about cost of water or curing compound or adhesion of polythene sheet has to be accommodated. Defects, whatever defects observed after striking forms should be reported to site engineer and through whom to resident engineer for decision of remedial actions proposals. No horizontal plans of weakness should be preferred. As far as practicable, concrete pouring should be planned for monolithic concrete actions. Construction joints should be agreed in advance for easy execution purpose. Wherever required, soil improvement has to be carried out to achieve required safe bearing capacity. SBC, that's called imported desert fill or graded fill, has to be used for purpose of limiting liquid limit as well as plasticity index to a maximum value. Backfill is one activity that makes a lot of difference on future of foundation. It must be rightly conducted. It has been observed that site engineers try to neglect its supervision and save project time by filling thicker layers than required. It's not a good practice. Backfill should be in good compliance to agreed specifications to achieve 95 to 98% field density. General fill can be compacted to 90% field density, that is general fill. Now construction sequence should be correctly followed during scheduling stage. Foundation should be planned as far as possible to be cast monolithic. Columns should be cast first. Beams and slabs should be cast one time monolithic. All connections should be done to meet requirements. It has to be ensured that proper bands are used in brick or stone buildings that have been required for equivalence. I already explained all this, I'm just repeating. Long walls should be inserted with bonding columns and bonding beams as required in specifications, and infill walls should be taken up for later after completing framework or structural work. Connections within columns and walls should be made with proper fastenings. Factually speaking, all construction activities must be complied with designs as well as specifications. Requirements, no negligence should be allowed. Quality engineers have to similarly be involved to check and inspect all activities by observations in addition to signing ITPs. Resident engineer should keep an eagle eye on activities. Quality product should be a must requirement. During earthquake or whatever service, every service too can break due to horizontal forces which require strong and durable fills around durable joints. All elements of buildings as well as finishing should be well secured and durable so that during horizontal impact of earthquake, these are not disassociated or torn out. Points for attention on site. Site should not decide self about whatever engineering design or engineering decision on mistakes for whatever reason whatsoever. Many aberrations from quality compliance and their suggested solutions are noted as follows. Rusted and bent rebars are delivered to site or to fabrication yard. Straight planes without rust only should be used. Reinforcing bars are placed on ground soil and not on good wooden or other supports without covering with polythene sheets. Precaution should be resorted to for good handling and storage. Fabricated rebars are not properly sorted out, tagged and stored in shed or under protection from moisture contact. Right tracking should be maintained by designations of relevant elements. Reinforcing bars dowels may be forgotten to place in at various joint connections. Chemical anchors should be used for forgotten dowels. Do not chip concrete to insert small hook. Drill shall be required to chemical anchors recommendations. Inserts, embedments of services at various levels, various locations may be missed. Approved job drawing should be used for checking inserts locations. Coordinate inserts locations to structural details. block out for various services may be missed. Approved shop drawings should be used to overcome such problems. Coordinate these locations to structural details. Sometimes, due to site negligence, certain concrete elements may be missed. By overlooking details, a structural drawing should be deeply coordinated with architectural drawings. Generally, facets dowels are forgotten, and many lintels too are overlooked, and many other connections are overlooked, depending on details. I have not given everything here. Opening or bulging of forms at 1/3 of height from pouring base is a common occurrence. Based on experience, location requires a strong resultant supports. It should be taken care of while considering concreting plan. Chipping should be avoided if feasible by providing strong supports. Honeycombing on surface is very common occurrence. Vibration should be applied rightly, produce a smooth and nice surface. Concrete temperature not ensured in range of 5 to 32 degrees Celsius. Concrete is done in temperature about 35 to 42 degrees Celsius. During higher temperature as such, ice needs to be added if mercury is about 32 degrees Celsius or say 35 degrees Celsius as well. Thick elements of massive blocks should be poured within 24 degrees Celsius range so that heat loss is allowed within reduced speed and reduced quantity. Voids formation in concrete is a common occurrence. Voids formation. Void areas should be chipped out or removed to strong concrete surface, followed by remedial treatments. Use recommended chemicals or concrete. Exposition of rebars or reinforcing bars is a common occurrence. Mortar is pasted on those areas to hide exposed rebars. Concrete spacers should be placed all over to meet a specified requirement, and vibrators should be applied correctly, and water cement ratio or mix must be made sure depending on what requirement there is. I have not written, but I am just telling you what happens, and we have to take care of concrete composition, concrete delivery very well, so that we do not create any void, and there should be no carelessness. One vibrator is done, other concrete comes, it should not be left unvibrated. Every concrete is left in for half an hour, so next concrete comes in, next comes in, then you must vibrate that. Do not leave that. Congestion of steel is generally seen, not anticipated. Congestion of steel reinforcement is generally seen, not anticipated by site engineers. It should be discussed with design engineer. If workable, a better arrangement should be approved. Either reinforcement bars are reduced, or you can say size is increased so that congestion is avoided, because congestion also causes some problems. Reinforcing bars are often displaced by electric conduits fixers. During conduits fixing, steel fixers should replace affected rebars parallel to conduits installation. For higher size rebars, overlaps do not work safely and perfectly, and I don't have confidence in overlaps to an extent. Mechanical connectors give. Mechanical connectors should be used. Generally, reinforcing bars diameter 20 mm and above work better when mechanical connectors are employed. Hardened concrete is, as a bad practice, cut for passing some small air conditioning duct already missed. No concrete should be cut without proper investment conducted by either design engineer or resident engineer. Now, excessive slump is not reported. Excessive slump is not reported. Excessive slump is not reported truly. No information should be concealed, but slump should be tried to be brought down by keeping truck mixers rotating for a couple of minutes. In case it doesn't work, it should not be accepted. Now, during concreting pouring, due to delay, additional water is mistakenly or secretly added by some people. No additional cube sample is taken for that added water batch, which is not an acceptable criteria, acceptable work. If it's allowed, special cubes should be collected for strength confirmation test as well as slump test. Construction joint stop end. Construction joint stop end is not readily available. You know what is construction joint. Where two concretes are done means we have to stop concrete, say, at one location. due to whatever reason or due to design criteria, then we have to make proper end of that. We should not leave as it is. There should be, vertical, half thickness of that place where you make construction joint, half vertical, then horizontal, and then half vertical. That should be generally done in case of, you can say, kind of rebate is created in that vertical section, half, then rebate, then half, like this, so that it should be properly done. It's not easy. You have to keep it ready all time, whether or not you may use it or you may not use it. It depends upon requirement. If it's given on drawings, then you have to do it no other way. But if for an emergency requirement, you have to construct that, you have to produce it. Should be ready made. Generally, thickness is done in it's not done in beams. It's done only in slabs, which may be 150 mm thick, 200 mm thick, 250 mm thick, 300 mm thick. So that much stop and rebate it, and you should. It's just not very big job. It's very small job. Even in pieces you can keep it prepared, means because there are so many reinforcing steel, so half and half you can take, or whatever you can take. Means concrete should to keep itself there, should be confined at that section, that line, and it may be in offset form also. So new concrete should be free of all this previous concrete. That's purpose construction joint. That construction joint stop and is not readily available, keeping any emergency or whatever else in requirement in view. Stop and should be made readily available if required. Is fixed as an emergency exercise provision when concrete stops due to whatever reason. There is a failure in supply, there is a failure of batching plant, or its design requirement, or whatever be. Construction joint is not correctly fixed. Location should either be indicated on drawing or should be agreed with resident engineer prior to commencement of pour. I am saying resident engineer because engineer may not be present all time. So resident is also engineer. You may decide. You are also contractor. You are also engineer. Both are qualified persons. So it's not a big deal. Construction joints not correctly either hacked or scaffolded, means when you are going to do new concrete afterwards, maybe after a gap of 1 day or 2 days. Long back, it was 48 hours. It was in 1980. It can be 72 hours. So construction joints not correctly either hacked or scabbled before new concrete is laid. Hacked or scabbled means you should remove all latents from surface of that. So the vertical, half vertical, horizontal rebate, and vertical. This must be chipped or hackled so that strong aggregates, hard aggregates are exposed. So construction joint is not correctly either hacked or scabbled before new concrete is laid. Do not run fast, but chip out joint surface to expose aggregates by removing latents and then proceed for laying concrete for new work. After merely cleaning it, all debris should be cleaned, everything should be cleaned, washed, and slurry laid. Or if requirement is there, bonding agent can also be applied. Standby vibrator is not available. That's a bad practice. It's very important to have additional vibrator to meet working requirements. In case of failure of vibrator, when busy vibrator fails, you can say vibrator should be checked for working before commencement of pours. Working vibrator as well as standby vibrator, both must be checked that this will work satisfactorily. Sometimes people ignore it and during vibration doesn't work. Curing is not started in time. Curing, which is really very much solution for concrete, life of concrete, it gives durability. Concrete is everything. Curing is, everybody knows what curing is. I need not explain that. Curing is not starting in time. Curing is not continued as required. Hot weather requires immediate curing, particularly on exposed or unformed surfaces. It can be done by spraying curing compound evenly. Polythene sheet can also be sprayed on concrete surface. Curing should be effectively carried out to define day by personal attention of site engineer. Curing is not completed for required period. That's another problem. And do not ignore curing. Ignorance can cause a major problem. And non-conformance report, NCR, we call it non-conformance report, on the quality terms NCR, on this count may have no solution for closing non-conformance report. It's an easy to pour concrete. It's very easy activity to pour concrete, but extremely expensive to dismantle and rebuild. Now here regarding curing, I would say something. When you use water, it's okay, fine, it should be curing curing water should be constructible. It should be used in construction, but also when you use curing compound for this purpose, your curing compound generally we spray immediately after that. Maybe it's damaged when activities, but yet curing compounds are particularly safe in fundamental terms of two types. One type is that we call it water-based curing compound. Of course, this is chemicals, organic chemicals, and we can say also that curing compound is water-based, and also curing compound is wax-based. There are two types. Generally, curing compound is based, when you apply this, if you apply curing compound water-based, it is 60 to 70% effective, and if you apply wax-based, this is 100% effective, but it's immediately requirement after concrete is done, and of course people shall walk on that. So even if you apply wax-based, it will go away. It will error out. So only difference is that water-based is used on that. Purpose is that at least protection to concrete is given from shrinkage cracks, from some other heat waves, from wind impact, or from humidity, whatever is there. You may say curing compound water-based can be used immediately for major purpose, and later on also when you remove shutters you can do water-based or wax-based, because you have to plaster surface later on. If you apply wax-based is more effective. In fact, it's 100% effective. It may be expensive also, but it forms a layer, a membrane on surface of concrete. And if plaster is to be done immediately, then that membrane must be removed, or it must be left for decomposition, and that decomposition of membrane takes about 6 months, maybe, probably, I don't know. It depends on manufacturers, what composition of compound they use, chemicals they use. They are usually used in that, which you have to inquire. But if you have to apply decomposition or debonding chemical agent on that surface, so that's what I'm saying is wax-based is more efficient than water-based, but water-based doesn't require that the debonding or erosion or remodeling surface. That's the only difference. So water-based is generally used. We can also use wax-based on those surfaces which may have to wait for, maybe you have to do plaster after 6 months or 3 months, it depends, but it doesn't happen generally. It goes on continuously. Maybe in 3 months maximum you have to plaster, but hacking has to be done immediately. If you have to do plaster on that surface, it may be ply or somewhere, that surface must be rough. So what we do, we immediately use after removal of shutters, and when curing is complete, people start doing on them some hacking. Hacking, if hacking, even if you have to use lath, if you have to experiment lath or something on that plaster lath on rending or on plaster surface, hacking is still required, hacking or scabbling, so that at least bonding between plaster and concrete surface access. So when you do that immediately, in that case, wax-based curing compound is broken, that membrane is broken, and that is good one. So that's purpose here what I want to explain. Curing is not complete for required period. Do not ignore curing. Ignorance can cause a major problem, and no conformance report NCR on this account may have no solution for closing. Non-conformance report is easy to pour, is active to pour concrete, but extremely expensive to dismantle and rebuild. Incorrect cut rebars, incorrect cut reinforcing bars are forced to be placed in an unusually bent, prepared good BBS bar bending schedule prior to starting cutting and bending. Bar bending schedule can be produced on Excel sheet duly using required formula. Cutting length should be shown with shape codes, and that formula it's available. It was available in BS 4466. It may be available in BS 886. I'm not going through that. It's available. Although shape codes have changed, they have extended many codes. But BS 446 is an easy one. For example, in that straight was 20 shape, means if bar is straight, just 20 shape code, and it was 37 if it's L shape, and it was I think 40 when it's one vertical, then little cranked in, then vertical, and it was also 61 that was ring shape, and 99 whatever shape. Like that, there were so many, maybe about 15, 20 shape codes, which have been very useful as far as 446 is concerned. I think 886 is also a good one. I not experienced that one because I didn't get opportunity to work on that. But it's easy. Our formula is 4466 on my Excel sheet, and it's very effective. I just use bar diameters and then formula A, B, C, D, E, whatever length it is, A, B, C, D, E, all you can write in that length. And of course formula is fixed in your Excel cells, and then cutting length is drawn, and after that I can say You can find total sum of cutting length, and you can find weight of that after adding 5%, or you can say 5% can be either for wastage later on. So you can say shape code is there, so that shape chart can be given to anybody. You can say, and these people know cutting length. When you go cutting length, it's not big problem for them. They won't calculate anything. They just cut that length and they will give shape to bar, and that's very good done. It's your responsibility. Don't depend on still fixers, because they cannot calculate to that extent. You can calculate millimeters, it's difficult for them to calculate like this. So this is very important. I'm saying, if you want to see, I'll show you this bar bending schedule format also, but that is an Excel sheet. I'll convert to and show you, no problem. Whenever I have a chance, I'll show you. Now at this moment I can't, I'm not ready with that, but it can be done very easily. So steps are not rightly centered. Do proper. Before that, I can say again, I read incorrect cut rebars or reinforcing bars are forced to be placed in or unusually bent bent shape. Prepare good BBS. BBS means bar bending schedule prior to starting cutting and bending. Bar bending schedule BBS can be produced on Excel sheet duly using required formula. Cutting length should be shown with shape codes. Stirrups or rings are not rightly centered. Do proper fixing work. Reinforcing bars are not centered properly. Do proper fixing work. And then reinforcing bars supporting chairs are not rightly cut for upper level steel. You can see not slab level steel, upper level steel, compression steel properly. Rebars supporting chairs are not rightly cut and fixed. Check before fabrication all required dimensions. Do not depend on steel fixers overconfidently. Rebars or reinforcing bars fixes complex activity. Make sure that it's done, it's carried out correctly. Reinforcing bars are not well secured. Bind bars properly without worrying about binding wire cost. Check fixing arrangements over all joints. Now tie bolts are not tightened properly. Tie bolts, you know what tie bolts are? Bolts are fixed in beams or in columns or whatever. Externally or internally, it goes through beams internally, also it goes into columns externally as well as internally, depending on your environment. It doesn't go through slabs and but only through beams, columns. So tie bolts are also in other sections, which are bigger one like lift forms. Walls also we go tie bolts. So tie bolts are not tightened properly. And of course, don't just leave it still in that. Use PVC sleeve or electrical straight bars. Put this PVC pipes in this, and let these steel bolts go in, and later get it out and fill that pipe with chemical mortar. Tie bolts are not tightened properly. Use correct dimensions. Tie bolts can fix properly as required. Plumb is not inspected to standards. It's difficult exercise to inspect dimensions, locations of verticality, but should be conducted particularly for elements to bear equipment or where facet is involved. Extra previous concrete is not chipped. Extra previous concrete means the past not chipped out. Sites should be kept tidy in all respects, clean, I mean to say. Chip all surplus required concrete. Otherwise, once it's hard, it's difficult to chip. Holes are not left for cleaning out dust from forms, particularly in vertical members. Holes are not left for cleaning out dust from forms. It's practically required to dust out preparatory works. Use compressor to clean out preparatory works. Flash setting is not prevented. Very important item, flash setting. It's a really practical item, you can say. Flash setting, F-L-A-S-H. Flash setting is not prevented. Use water to be sprayed on forms to keep temperature low before concrete starts. When steel bar is hot, concrete is cold. Combination generates flash setting of concrete avoided. And also your shutters are hot due to whatever reason. Maybe you can't say plywood is hot, but if you use steel plates or if it's something else, that's the same thing as steel rods, steel bars. So if you use steel plates, means plates are also hot, and concrete is in a temperature range of less than 32 degrees, and say this may be 50 degrees, your steel So these do not work in, you can say, compatible with each other. Concrete is, when concrete is laid on the surface of steel, steel heats up that concrete particularly, and it causes problem in concrete. Flash setting, it is in that part. Flash setting, in a sense, first temperature is higher. Okay, temperature of concrete you reduce, so that temperature environment won't do anything, but surface of steel is hot. That may be 50 degrees, for example, 45 degrees, and your concrete is 25 degrees, 45, 25, there could be a difference of 20 degrees between two. Means temperature of steel is 45 degrees Celsius, and temperature of your concrete is 25, say 25 and 45, 20. So a range of 10 to 25 degrees can cause flash setting, which can reduce value of concrete, structural use of concrete, and it cause cracks or something else which you can't. Means that's a problem. So better spray water before starting concrete. Use water to be sprayed on forms to keep temperature. Forms means on steel also, immediately you have to cover that to concrete. Use water to be sprayed on forms to keep temperature low. Means temperature in volume of concrete. Temperature we have to do concrete. I'm not saying environment temperature. Where concrete is coming in the body of volume of where shutting is ready. Use water to be sprayed on forms to keep temperature low before concreting starts. When steel bar is hot, concrete is cold. Combination generates flash setting of concrete is avoided. Cold joints are wrongly allowed. That's now a special item. Cold joints. Cold joints sequence should be made as such that concrete repetition is done fast in hot conditions. Time gap should be controlled first when to this cold joints. Why cold joints we call them? When there are two batches of concrete, there's a gap in between them. That's just a point where cold joints are formed. Say you did concreting, you vibrated it and left it, or you forgot even to vibrate. Unless there's a gap of half an hour, 1 hour, by chance there is 1.5 hour, 2 hour, next batch is not ready, available, and you have to receive it later on, and you don't care about anything else. So I vibrated that left, or even didn't, okay, I vibrate later on to it, but we have to be very careful. Even if you did not vibrate, you have to think of, suppose there's a delay in next batch to arrive, immediately you vibrate, even don't wait for 10-15 minutes. If you wait for 10 minutes and see it doesn't come, okay, fine, 10-15 minutes, also you can say setting time starts. So immediately apply vibrator, don't wait. Even there's lapse of 10 or 15 minutes. And if you don't apply, then concrete starts hardening, and it will cause void or honeycombing or something else. It's no use. It will cause problematic concrete. So better is don't forget apply vibrator, and suppose there's a delay in concrete. Your concrete starts setting in, you can't lay new concrete on that. So if you lay new concrete, it will be cold joint, because laid concrete is already cold, new concrete is hot, there's a difference in temperature of two. It's the problem. So either if you think there's a lot of delay, better postpone. If there's a gap of say maximum half an hour, 30 minutes, okay, that means the initial time of concrete is still green. So let it be green. Once you say, well, it's within limits, or you cancel that pour and make construction joint. Even if you are doing slab, that's the big point. And if there's no way, then you have to deal concrete accordingly. And I think this is a problem. Best is do it, level it, make it in shape, and what I can say, make construction joint. Don't allow cold joints, and if there is a failure in batching plant, let standby plant start working and provide mix. That's an only way to keep cold joints off your pour, because cold joints creates problem. It doesn't work according to conformance requirement. Concrete is collected at one spot for longer than required. Concrete is collected at one spot for longer than required. Do not pull up concrete. What they do, they pull concrete at one place on slab somewhere, which is wrong actually. It should not be pulled up because it carries weight, load, and it can cause problem in supports. So It's collected practically, I have seen, at one spot for longer than required, say a keep of half an hour, 1 hour. Do not pull up concrete at one location. It is dangerous for preparatory works and scaffolding. When you receive concrete, some persons have to put in or spread it by using your teeth shovel or hand shovel, whatever is your provision. Do not pull up concrete using vibrator. Do not pull up concrete at one location. It is dangerous for preparatory works, that is shutters too, and scaffolding as well. Pulling is not accepted or recommended. Spread it evenly and use your vibrator. Don't allow pull up, because pumping is very fast and people can't handle it exactly. They do this, but spread it better. If you spread it on wider area, at least load would not concentrate at one place, and we can handle that. Workers add additional water to soften concrete due to delayed following pour. Do not allow such addition of water, as we discussed before also. This is not acceptable. Remedial actions on defects are carried by site staff. Remedial actions on defects are taken care by site staff without even informing site engineer. Keep an eye on foreman or supervisor and other persons who are responsible for this, and they should be instructed not to do this, because whatever defects are must be discussed with engineers, resident engineer and others, and resolution must be taken out so that concrete is concrete. Do not hide it. Defects are expected in concrete due to various hands work on same thing, and there can be lapses in activity. So defects should be exposed and corrections made, remedial actions made. That is in interest. Maybe you spend some money on that, but it's better for, because there was negligence on your part, there was carelessness on your part. That's why defects appeared. Otherwise, there's no meaning of defects. For work is removed or struck before the defined time limit. Record dates in concrete register for all pours. Record all test results, record all curing dates, and record whatever is possible to be recorded, because it may be used for investigation purposes in future also. Now, concrete blocks are shifted from factory to site. Concrete blocks, hollow blocks or solid blocks. Concrete blocks are shifted from factory to site within 3 days of production due to shortage of space in factory and heavy requirement on projects. Due curing is not allowed, means whatever curing you have to do on these blocks is not allowed. Concrete requires curing according to concrete philosophy, concrete can say concrete requirement. Due curing is not allowed. Cure blocks prior to being tested and permanently included. What happens when you bring 3 days, immediately say the person who sends for testing these blocks will certainly fail, because in 3 days it can't pass. So think of, ask that block manufacturer day of production on your delivery. If day of production, you can say it's 3 days old or 10 days old, and during cure or not, and curing can be done on site. So it causes problem, and I experienced this problem during my career. That's why I'm reflecting here. Now, class 1 bricks are not procured or even not available in our country. I have seen there's no class 1 brick, but they call it class 1 brick. You can call anything. Procure good bricks or blocks. Avoid using weak bricks. Don't buy weak bricks. Don't buy defective bricks, and don't buy bad blocks. Wooden planks are used for formwork. I don't like it, but here, people do it. Wooden planks which are not even well edged, well plain edged. There's gap between all. Wooden planks are used for formwork with leaking joints. I say the gap is there, leaking joints. Better suggested use ply for good results. If you have repetition, ply can be used up 4 to 6 times. If it's commercial ply, it can be used 4 times. If it's marine ply or waterproof ply, it can be used up to 5-6 times, or 5 times or 4 times. You can plan accordingly depending on whatever surface area you have to shutter, and buy accordingly. Formwork is not correctly labeled. Set out formwork properly, check all lines and labels truly. Now, grouting of structural steel bars. Grouting of structural steel bars that are generally RCC foundations. Grouting for structural steel bases that are generally RCC foundations requires a good control as it's cement-based material. Similarly, grouting for under-anchorage plates require good controls. And grouting can be done by cement when machine is stationary or vessel is stationary. It can be of epoxy also, epoxy mortar when it is vibrating machine. Do not go ahead for whatever work. Do not go ahead for any work where doubts exist, either in specifications or in design. Obtain clarified answers in form of site technical queries before carrying out before carrying out ambiguous items. So do not go ahead for any work where doubts exist, either in specifications or in design. Obtain clarified answers in form of site technical queries before carrying out ambiguous items. It is emphasized that points which I explained, the foregoing points, should be considered in true spirit. Carrying out better work on controls shall definitely produce a good concrete work that may serve to required and desired durability, with desired durability or reliability for whole structures. On building, I am writing durability only, but it should be reliability, means it should be safe, it should serve, and it should be long living, which is durability. Patience pays on site, no panic, right? Patience pays on site. Panic harms works. Plan properly all day-to-day activities. Progress is required but not at quality cost. Safety first slogan has to be applied in all respects. Safety is responsibility of one and everyone. Site engineer has also to be involved with retrofitting activities. Seismic retrofitting, structural modifications to upgrade strength, ductility, and energy dissipating ability of seismically deficient or earthquake damaged structures. Seismic strengthening process of enhancing strength of existing structures to make them resistant to seismic activity, ground motion, or soil failure due to earthquakes. Identifications. Identify various priority buildings such as schools, hospitals, nursing homes, police stations, fire brigade centers, multi-story buildings, water reservoirs, electrical stations, essential services buildings, etc. All surveys of restorable buildings. All surveys of restorable buildings can be done by experienced site engineers minutely for purpose of making a report to decision makers. All details from site observations and samples collected from sites can be reported to laboratories as well as to relevant engineers. It requires an extensive grasp of field knowledge. It requires an extensive grasp of field knowledge of state of chronic materials. Recording can be done by photographs, video by taking all measurements of locations of deteriorating areas. Hand excavation should be effected for purpose to collect foundation sample of old concrete. Rebar or reinforcing bar sample can also be collected from non-critical areas that require a good study of structure, either from records or from site surveys. Engineers should have patience while working on retrofitting. Detailed report should be submitted to have an understanding about health of old building or structure. Levels at various heights should also be recorded to reflect major settlement. The flexions of members could also be recorded if feasible. Record all applied real loads on buildings either by inquiring or observing. These can be different than whatever have been used in designs. Columns and beams are required to be studied with concentration. Strengthening of these members shall be very difficult. Check all deformations and deterioration. You may have to apply jacketing, you may apply so many other, you may have to do so many other issues, you may have to, you will find cracks, you will find so much deterioration of concrete or loss in strength. There could be whatever reason for that. Similarly, samples and integrity of wall materials should also be recorded for making good report. It may be proposed to add beams or extend footings in foundations for which all existing data must be collected. It's not easy. Remember, additional columns or beams could also be required to be added to meet various requirements. For that, all necessary data should be recorded on report. Retrofitting could also demand provisions of composite sections into existing one. Careful study and understanding is required for all such cases. Retrofitting requires great input by investigation engineers prior to making whatever decisions. For certain structures, it may be better to rebuild as a whole, while for others, retrofitting would be economical. Whatever be considerations for retrofitting would be detailed method statements giving minute sequences, shall import attention, and site engineer should include all such details with elaborations for making a clear understanding of proposal. All work would certainly impact on budget. If required, the porting can be done by many stage inspections that may depend on size of structure. Separate individual records are suggested to be made for a proper audit. Complete audit should be worked out. Post-earthquake disaster management. No one can control disasters, whether it is caused by earthquake or by other calamities. Preparedness to mitigate whatever disaster is required. Everybody should be ready to accept responsibility. Major contribution would be required from various disciplines such as indicated below: police, army, fire, brigade, civil defense, medical professionals, equipment companies, expert operators, helicopters, cranes, civil engineers, NGOs, activists, volunteers, etc. In action being government constituted to coordinate, control and assist nation out from clutches of disaster. National Disaster Management Authority, well, this is different. There should be vision, zero tolerance to avoidable deaths due to earthquakes. Mission is to formulate guidelines for preparation of plans to reduce earthquake risks and minimize impact, loss of lives and damage to property caused by earthquakes. And then term definitions are disaster, hazard, health, high risk areas, disaster management, mitigation, non-structural measures, preparedness, risk assessment, risk management, rapid visual screening. This will take later on because we have to, this is not actually, or you can read it just in 2-3 minutes, doesn't make a difference, better just for your knowledge addition. You can risk it, you can say, it's not very long, just 2 pages, wide waste, disasters, high risk, let us say, from where I like to say. Okay, term definition: disaster, a catastrophe, mishap, a catastrophe, mishap, calamity or grave occurrence in whatever area arising from natural or man-made causes or by accident or negligence which results in substantial loss of life or human suffering or damage to and destruction of property or damage to and degradation of environment is of such a nature or magnitude beyond coping capacity of community of affected area. Hazard, a threatening event or probability of occurrence of a potentially damaging phenomenon, an earthquake, a cyclone, storm, or a large flood within a given time period and area. High risk areas, geographical areas which fall under seismic zone in Bharat, India 3, 4 and 5 which are vulnerable to potential impact of earthquakes, landslides, rock falls in mud flows. Disaster management, a continuous and integrated process of planning, organizing, coordinating and implementing measures which are necessary or expedient for prevention of danger or threat of whatever earthquake caused disaster. Then you can say Disaster management, a continuous and integrated process of planning, organizing, coordinating, implementing measures which are necessary or expedient for prevention of danger or threat of any earthquake-caused disaster, mitigation or reduction of risk of any disaster, mitigation or reduction of risk of whatever disaster, or you can say its severity or consequences, measures aimed at reducing the risk, impact, or effect of a disaster-threatening disaster situation. Capacity building being preparedness to deal with whatever disaster, prompt response to whatever threatening disaster situation or disaster, assessing severity or magnitude effects of whatever disaster, evacuation, rescue and relief, and rehabilitation and reconstruction. Non-structural measures to reduce or avoid possible impacts of hazards such as education, training, capacity development, public awareness, communication, etc. Preparedness, state of readiness to deal with a threatening disaster situation or disaster and effects thereof. Risk, expected number of lives lost, persons injured, damage to property, and disruption of economic activity due to particular natural phenomenon. Then risk assessment, determination of nature and extent of risk by analyzing potential hazards and evaluating existing conditions of vulnerability that could pose a potential threat or harm to people, property, livelihoods, and environment. Risk management, process of using systematic process of using administrative decisions, organization, operational skills and capacities of implementing policies, strategies and coping capacity of society and communities to lessen impact of hazards. Rapid visual screening, that's obvious. Rapid visual screening, a procedure requiring visual evaluation to assess vulnerability of buildings by permitting vulnerability assessment based on walk around of building by trained evaluator. Evaluation procedure and system is compatible with GIS-based city pathways and also permits use of collected building information for a variety of other planning and mitigation than specific risk. Expected degree of loss due to particular natural phenomenon can be assessed in whatever area. Seismic retrofitting, structural modifications to upgrade strength, ductility, and energy dissipating ability of seismically deficient or earthquake damaged structures. Seismic strengthening, process of enhancing strength of existing structures to make them resistant to seismic activity, ground motion or soil failure due to earthquake. Point requiring attention, new buildings should be properly set out to allow easy access to areas for rescue operations. Adequate access should be included for machines and equipment to enter. Equipment must cover as required in EQ situation. Buildings should be located away from main roads. Streets should be wide for easy access of vehicles and equipment. Priority and essential buildings should be in vicinities. Standby generators plants should be provided to meet supply failures, and firefighting lines should be available during emergencies. Roads should be resistant to earthquake forces. All existing structures prone to failure should be upgraded by strengthening or retrofitting. Trained and certified engineers and other personnel should be available all over. All these personnel should be given updates and allowed still drills. Similarly, medical professionals should be given updates and allowed drills. All other relevant professionals and others should also be updated and allowed drills. General public should be kept well informed and imparted education about methods to respond during such emergency of earthquake without panic. Engineers can do this job very well. Owners should be educated about benefits to include earthquake resistant design, provisions on new structures. Engineers can very well explain to public. Similarly, engineers can demand from architects to include earthquake requirements, provisions on new buildings, in public sector or private sector. Engineers can deliver lectures on schools and colleges about earthquake requirements, methods, and about role of children and public involved. This is another one, I think. Same. I'll let you see that role, EQ management role. There was another role, I think. So that I am project management, I hope. Okay, let me see which is that. Project management. Let us open this document. I think I say building house. I'll say building house here. This house building, which was discussed before. It's also a good one if you take this into consideration. This was there, and I think it should be 150. Electric. Okay. I'll just go through briefly on this because it was also discussed that we did not go that continuously, and this should be done now. It's if you take I have to give me 5 minutes because I have to go for 5 minutes and come back. I have to daily routine it is. Just give me 5 minutes, I'll be back. Okay, dear friends, hold on. Here's my glass. Sorry to delay, so I'm sorry. A little delay due to something. I'm sorry for that. Some delay was there because of some reason, and I apologize for that. We continue with this. We continue with this program I was talking of. House constructed long back in near Delhi, in Faridabad. Faridabad it was. It is really important issue. We did that, and I'm sure that purpose of my statement is to describe something, So let us see first what he wrote in that. Refer to safety chapters, semester is 12, so we'll take care of that, don't worry. My purpose is different. Safety standards have to follow. Don't miss safety to keep that economical, though that's not purposeful. Just considering economy on project cannot exclusively be criteria to avoid safety. And this is, I talked to you yesterday. This was the house. Let me go through this page first, just 17 pages. Design method procedures we did, safety, references, materials methods, excavation, blinding, foundation, basement walls, ground floors. Then you can say various actions, various activities, and of course you can say what we did on that. This is a sketch, which is a very important one here. You can see this plan, structural plan here. You can see this portion here. This portion, there was some portion here. This is the different details here, but I'm talking of this portion, which is extended house structural arrangements. You can see here, columns and beams are seen in this, and also you may say that plot size is 420 square meter. Basement is below, ground cover is 55%, total cover is 540 square meter. And this again structural drawing features are there. I will take care of that later on. Now I am just interested in showing you actually what is required here, what we did. You can see here, this is foundation beam. You can see size of this beam is 400 mm by 1200 mm with 400 by 1000 here and spreader here. This you may call it damper also, or buses part. Is not T-beam, don't be confused with that. And this is soil improvement here she provided, because existing soil is clay. So 40 or 400 mm, 1000 mm or 1012 mm like this. This is main beam, which is used, we have been used for resisting movements, and this is just a spreader to make wider area, and this is soil improvement. Then we go further and see what else we did in this specifically. We can say that we did in this, and that was specifically done. But we crossed fast, I think, better. Yeah, this elevation, this is right elevation, or you can say south elevation. These different types of windows to provide as much light into room, as much ventilation into room. You can say this is like the slab, so this much all. And this staircase, you can say ventilation here as well. And this old structure here was built, and this is a new structure, this old structure. In old structure, because this is abutting to other buildings, so there's no ventilation here. But here we set off driveway this end, so this is basement portion. There's no access, some ventilators here, there's nothing. So this is that, and here is another elevation, that is left or north elevation. You find this old building, and this is new building, new construction. And you can see here also same type of maximum ventilation, maximum glazing here as well. That's what is provided. And then now you can see this sketches, this is This is, you can say, another elevation for that. Here it is, balcony, front balcony, whereas I think this is front elevation. Yes, it is front elevation, and this is distant old construction elevation, and this is stair above with this ventilation here. This is rooftop, and this parapet here. You can see these windows again, this basement ventilation here. If you go down further, architectural plan, first floor, this portion is double height, this is balcony, first floor level, this stairs, the steps in that, and this old construction, this is new construction. And you can see this you can see here, balcony going continuously, and we can come in here, just like you can see, we come in here, we can go out like this, upstairs, up steps, then we can move around, and this is then again down steps and go like this. So it's kind of a ring walk at first floor, ring walk at first floor. These are bedrooms, this is prayer room, first floor, and this balcony. And below is hall, as in this portion. And this is main. Actually, I'm intended to concentrate on this. You can see this is here. This is what is actually, this is here. What I want to show you. This is foundation. That's the important point in this is foundation is this. That's the important point. You can see this is 400, this is 1000, this is 200. This is our foundation beam continuously. There is no independent footing, there is no raft. This is just this beam connecting all columns, and columns super or dwarfed column, or you can say stub column will start from here, steel of column will go inside, and you can see these are main bars, and these are main bars of generally 12 mm diameter, and this is spreader here. You can say kind of damper, the horizontal force will resist by with this ring here, steps, and all this. You may say how many bars are there, and this is just foundation continuously as seen in this plan. You can see here this plan, all columns are connected. You can see that all columns are connected, and all columns are connected here. Of course, beams designs reinforcements are different, but I'm just indicatively showing you what is that. And that is what it is, this beam section, and here is these are beam continuously moving around here like this. There's a water below basement water reservoir, 16,000 cubic meter, and this is front here, this side. So this is foundation beam rebar plan here. That was I did. Then you can say here is, this is of course same. Here is excavation area. Of course there is an access here on the ground, but this is just for indicative purpose. That's what we did. And these are beams here, but this all excavation. There is no beam excavation, all excavation, and the whole area was excavated, and this was done. The excavation plans constructed like this, and there was there's this and his driveway and this and the offset. So we just proceeded one construction access here from ground to basement. Now we can say that some lessons were learned, and what were those lessons? We will talk of that in this. You can see this is purpose of this. And let's end off this brief note. Now I would like to just go back and tell you what a kind of revision on this paper, on this statement, what we did, how we did. I'm just going to explain it, not sentence by sentence, but closely. And this is house built in NCR, that's called National Capital Territory, National Capital Region, and that's an important point here. Purpose of this method statement is to describe in brief procedure that were adopted for one house construction in NCR, Delhi, long back. Synopsis of engineering construction provides brief details later. Basement, ground, first, second floor, penthouse. This is the construct basement, ground, first, second floor and penthouse. Penthouse or second floor, same here now. So basement plus ground plus first plus second. All RCC structures from basement to penthouse, including RCC basement walls. Walls in bricks at all levels. Walls in brick at all levels, only for cladding purpose, not for structural purpose. Door windows, aluminium. New structure. Existing old structure about 80 square meter with wooden doors, RCC structures. Design of whole building, all disciplines including connection to old building. Now what was method they adopted actually? That's the point we have to talk about now. All design disciplines were conducted self. All design disciplines were conducted self without any aid from architect. Offsets, joining, architectural plans, elevations, sections and detailing were conducted self. Structural analysis were conducted using Carney's rotation contribution method, for which self-formalized Excel templates were used to reach movements, shear force, deflections, seismic impacts, etc. Designing was also conducted using custom self-formalized formalized Excel templates for beams, columns, foundations. A bar bedding schedule were prepared using Excel sheet, duly formalized in line, and consideration to BS 446 shape codes, which is now 8866. Safety. Access ramp was provided for access to foundation pit, used by personnel and donkeys, workers both. Scaffolding was procured in form of pipes as well as wooden valleys, props. Timber safety railing was used on sites to prevent falls, and PPEs or personal were used to requirement. It's unfortunate to know that workers in our area do not respect use of PPEs. Access ramp was provided. Okay, now drawing included within synopsis, which I have told you. Now, what specification? General, international, national, both used. It says now local materials from various sources. Local materials from various sources are procured for all activities. Structural materials and ingredients were procured from poly crusher quarries. Reinforcing bars procured in full length, as 12 or 40 meters without being bent. All reinforcing bars were fabricated on site only under direct supervision, my direct supervision. Concrete was mixed on site. Since RMC was not consistent in quality, formwork was designed using plywood and wooden batons, both hardwood and softwood. Setting out was done by old methods of formation of a right angle triangle instead of using the theodolite. All references regarding grids and levels were established on existing walls around excavated areas. Existing soil types is silty, clay with sand, strata 20 meters depth. No rewatering required since water table is much below. Excavator JCB equivalent was utilized for excavations up to limited depths and limited setting out. Reason was that on three sides buildings existed which did not permit full excavation by machine, requiring manual means for further work. Donkey workers and masters were used for remaining excavation to each formation level. Excavated metal was removed from site immediately as and when it was dropped into truck or onto tractor trolley or into temporary stockpiles. Sites of excavation were protected from erosion by covering with polythene sheet so that rainwater does not help loosen strength in this case. Horizontally inclined bracing supports were not required due to nature of soil. Since soil bearing capacity is not safe to allow heavy structures in this formation, because of clay, soil improvement was conducted by including low formation level and improved layer of 300 mm thickness deep as explained later. This layer composed of aggregate and coarse dust. This layer composed of aggregate and coarse dust duly watered and compacted so that it should also function as a coarse accredited strata. On this layer, an application of tape-grade coatings or polymerized cement was carried out for concrete protection. Coating of tape-grade was or polymerized cement was covered with a plaster screed of protection. Preparation for blinding was affected and blinding concrete laid to whole area. Blinding was secured to requirement of 3 days. Foundation. Setting out foundation raft. Part of foundation beam was conducted. Preparation of raft included placing fabricated reinforcement, fixing of forms to sides of proposed raft, fixing spaces, cleaning whole RCC spaces. A special waterproofing compound was procured to be mixed. Compound was fixed with, compound. Special waterproofing compound was procured to be, what I do? Why does this come? Why does this come again? Close it. A special